Alright, so we're going to look at some trig ratios to both help find the ratios and using the ratios then to find a side length. So let's start with number 1. It says write ratios for sine of x, cosine of x, and tangent of x. So first they're referring to x, so we find the angle marked x. Then we can label, alright, opposite from x, that's our opposite leg. The side across from the across from the right angle is the hypotenuse. And then the side that is next to x is our adjacent side. The side that is next to x but is not across from the 90-degree angle. So now we have labeled adjacent, opposite, and hypotenuse. So we can remember our so, ka, toa. Sine is opposite over hypotenuse. And then we just put in what we have labeled because we did everything in terms of x. So the opposite leg from x is 8 and the hypotenuse is 10. And make sure to reduce that fraction as many of you guys did in your homework earlier this week, which was awesome. Cosine of x was our adjacent all over our hypotenuse. So we go to x, we find the adjacent leg, that's 6. The hypotenuse is still 10, and then we reduce that fraction to 3 over 5, dividing both 6 and 10 by 2. Then tangent, we know, is toa, opposite over adjacent. Our opposite leg from x is 8. Our adjacent leg is 6, and we can also reduce that by 2, and we get 4/3. So that was a quick review on writing the trig ratios for different angles. Now let's go to number 2, which is going to talk about how to find a side length based on a given ratio. So let's look at A together. For letter A, we see, all right, I have this angle. So I'm going to write everything in terms of this angle. This leg is going to be my hypotenuse since it's across from the 90-degree angle. Now the side adjacent to the angle is this one, 12. The side that's adjacent, that's not the hypotenuse. And then the side that is across from the angle is the opposite angle. So I need to find x. I could really write 2 different ratios to find this. We could either use tangent, because we have opposite and adjacent, or I could use sine, because I have opposite and hypotenuse. Let's do both. So tangent of 22.6 degrees is equal to my opposite over adjacent, which in this case is x over 12. Now if I type in my calculator tan of 22.6, I will get a decimal value, and then I multiply that by 12 to get x. So I'm going to come back to that and do the decimals in a second. The other way I could solve this is I could say that sine of 22.6 degrees equals opposite over hypotenuse. And the opposite leg is x, the hypotenuse is 13. And then I could multiply both sides by 13 to get 13 sine of 22.6 degrees is equal to x. So we should get the same thing for both of those answers. After typing those values in my calculator, we get that 12 tan 22.6 degrees, and then when I typed it in Google, I wrote 12 tan 22.6. I had to write degrees, or else you get the weird radians type. Alright, so you type that into Google, and then you get 4.996. It repeats forever. You round it to 5. Same thing for sine. So you could check sine. Down here, you could have typed in 13 sine 22.6 degrees. If you type that into Google and hit enter, you should get the x is 4.996 repeating forever, and you round that up to 5. It should make sense. This is a 5, 12, 13 triangle, which is one of our special right triangles. All right, let's look at letter B. So for letter B, we have this angle that we're looking at. So for this angle, this would be the hypotenuse, because it's across from 90 degrees. This one would be opposite because it's opposite the angle, and this one is the adjacent. So what do I have? I have the opposite and adjacent leg. Opposite and adjacent, that makes me think of tangent because of TOA. So tangent of 35 degrees equals the opposite over adjacent, which in this case is 40, all over x. Now this one's a little bit harder because x is in the denominator. That means we need to multiply both sides by x first. And then divide both sides by tangent of 35. So into Google you can type 40 divided by tangent of, and as long as you write 35 degrees, you should get the right answer. Though if you don't write degrees, it's going to assume that it's radians, and that's going to give you a very wonky answer. So make sure you type the degrees part.